I many times read about the gimbal behaving like a chicken with its head cut off, jumping around uncontrollably. So I want to go through a few steps that I think make it much easier to tune the gimbal quickly and sort of do it in a way that take a lot of the guesswork out of the process. So let's get started. All right, let's go through the prerequisites that you want to have in place. You want to install the latest version of the GUI. We're using 2.3 here. Also download the latest version of the firmware. You want to make sure that you have the drivers installed so that you can actually make a connection between the GUI and the board. If I click connect here, I actually get a good connection. If you don't get a connection, there's no point in continuing. You need to debug that first. There's a lot of information available online on how to find your right COM port, how to maybe set the COM port to a lower COM port, etc. The next thing is you got to make sure that the gimbal is mounted and operating in a way where nothing is binding. So everything has to be sort of easily turned, and there's no pushback from any cables or anything like that. The next thing is you got to make sure that you have the camera mounted in the gimbal and that the gimbal overall is well balanced. Many times people would try to tune the gimbal without a camera in it, and it throws off the balance and you will never be able to tune your gimbal up. The first step is to put in some values that will help you during the tuning process. And it really doesn't matter what the exact details are of your PID values here, but I like to start with values that are like, let's say 10, let's say 0.4 for the I, and 6 or 7 to 8 for the D. So you're going to put 10, 0, 4, 8 for the roll, and 6, 0, 4, and 6 for the D here. Next, on the motor configurations, leave the power values for both roll and pitch at 0. For most of the setup, at the beginning of it, we'll leave the power at 0. That'll help you make sure that everything else is set up properly. Number of poles, for the most part, you'll be using 14, unless your motor is using a different pole count. The QAV airframes, for example, the QAV 400 gimbal will ship with the 2208 Tiger motor, gimbal motors which have 14 poles. The QAV 540G uses iFlight 2208s that are also 14 poles. So leave these numbers at 14. So now we're going to ensure that the roll and the pitch motors are connected to the right connections on the board. We have our roll and pitch at 0, the power. And before we start, we want to calibrate the accelerometer ones. Right now, the GUI is telling us accelerometer is not calibrated. And we'll do that a few times during the process here. But we're going to do it once just to get rid of this message. To do that, you'll hold the gimbal, and right now there's no pushback, so it's easy to hold the gimbal in place. I'm going to click Calib AC, so calibrate the accelerometer. Next, we're going to set the power for the roll motor to a number like 80 to 100. Let's say we're going to put in 80, and we're going to write that to the board. And what we want to then check for is whether or not the roll of the gimbal actually has power. If we have the motors reversed on the board, we will feel the roll be dead just like it is now, so there's no power, and the pitch has power instead. So that will tell us whether or not we have the motors reversed. So we're going to write this now. So now we get the crazy chicken dance here. But we can see that we have power on the roll motor, and the pitch is still dead. So I can move the pitch around, but the roll is going crazy. So that tells us that the motors are connected properly, and that's a big first step to get the gimbal tuned properly. Okay, now we want to check if we have the sensor values for the IMU set up properly. And it really depends on how the IMU sits in the gimbal. In our case, the IMU is at the back of the camera and it's sitting on its side. Many gimbals have the IMU on top and it sits horizontally, but in our case, it's in the back and on its side. So we have the power of the motor set to 0, so we can easily move and hold the camera. The first thing that we want to do is hold the camera and the gimbal in a way that it's level, and then calibrate. So we're starting off with a properly calibrated IMU. And then we'll look at the dials for roll and pitch and see what we have. So in this case, if I'm rolling the camera, I get no feedback from the roll dial, so that's a problem. The pitch dial is on its head, so that's a problem. And also if I pitch, I actually see the roll moving. So we have quite a few problems that we need to work out. So let's start with getting the pitch to work as it should. So right now, if I pitch the gimbal, I get no feedback on the pitch dial. So that means we have to change the right value of the sensor. So right now it's set to Y, and I'm going to switch it to X and write that to the board. After I do that, I have to again calibrate the IMU. So I'm holding the camera and then calibrating it again. So now I can pitch, and I can see that while the arrow is pointing in the wrong direction, if I move the camera on its pitch value here, you actually see the pitch going. So we know that at least we have the axes correct. Now, let's check the roll. So as I roll the camera, I also see that I have good feedback on the roll. So now, let's try to get the pitch pointing in the right direction, and that means we have to change the axis top. So right now we're using X for the right, so and Z for the top, so that only leaves Y to try for the axis top. So we write that to the camera, we calibrate the accelerometer. Okay, now the pitch looks good and the roll looks good. Let's see what happens when I pitch. So pitching down on the camera actually pushes the arrow up, and looking up with the camera pushes the arrow pointing down. So we know that we have to reverse the pitch. So that means that instead of axes, instead of the right being X, we actually want to flip that to right being minus X. So we're going to write that back to the board and then calibrate the accelerometer, and let's try that again. So now as I look down with the camera, the arrow is pointing down. As I look up, the arrow is pointing up. So we know now that pitch is correct. Let's check the roll. So I get roll feedback. We just want to make sure that it rolls in the right direction. So as I roll left looking at the camera, you actually want the dial to go in the other direction, and that's happening here. So I push the camera left and the roll dial is moving to its right, rolling right. And the way that this works is that you normally are supposed to look at the frame from behind the frame and looking in the same direction as the camera does, and in this way you'd actually mimic the motion of the camera just like we do with the pitch. So we now know that those are our values, Y and minus X. And if you want, you can calibrate one more time, holding it really level, and then also calibrating the gyro. And now we have a well calibrated IMU. Okay, now we're going to move on to looking at the invert value. And we're going to use the auto function to be able to figure out easily if any of the motors need to be inverted. So now we're going to put some power on each motor. Let's do a low value like 80 and 60 in my case for roll and pitch. We're going to write that to the board, and the gimbal now springs into action. It's already sitting level because we know that our sensor is set up properly. So now we're going to click on the auto button here within the motor configuration. So this then is starting to turn and move the gimbal and tries to figure out if any of these values here need to be checked. So we're going to let this finish. Okay, so it did a couple of things. It checked off the invert value for pitch, but it also changed our number of poles. And that you have to look out for. Right now it's using 12 for the roll motor, but that's not correct. We know that it is 14, so we're going to put this back to 14. Once we've done that, we can write that back to the board. And now we have the motor direction properly configured. So now that you have all the values set up properly and you know that the motors are connected correctly, you can start your tuning process. I'm not going to spend much time talking about tuning. A couple of things though to point out is I like to make sure that the motors are giving me adequate pushback when I'm moving the motor. So I don't want the motor to be sort of too weak. In this case, if I'm pushing the roll motor, I get very little pushback. So I like to then increase my values here, let's say to 100. Let's see that. It's a little bit better, maybe even a little bit more than that, 110. And that works a bit better. The other thing you want to know about is the I value. That's the speed at which the camera will return to its origin. It's a value that is now goes from 0 to 0.5. So if I go to 0.05, let's say, I'll see that the roll will take forever to return to its origin. So I like to see it move slowly but not too slowly, so let's try a value of 0.3. Write that to the board and then try that, and you'll see the motor moves the camera back into position at a nice slow pace.